Welcome to Physics in the AM. I'm your host, Joel Shindelic. You don't, do you have something yet? Not a name yet. Hopefully tomorrow, to be announced. 4.1, speed and velocity lesson here. I was mentioning speed, no direction, it's a scalar. Velocity is like 100 kilometers per hour going north. Okay. This formula here, V equals d over t, only works if your speed is constant. Okay. Now we're just starting this up, and then I realize how to record. You travel down the highway, say from Saskatoon to Regina. You're going 110 for an hour and a half, and you hit Chamberlain. You slow down to 50 kilometers per hour for 6 minutes. After that, you go another 30 minutes at 115 kilometers per hour. What's your average speed? It was suggested. Can we add 110 plus 50 plus 115 divided by 3? No, because that 50 kilometers per hour brings it down. That would only work if you went half the trip distance-wise at one speed, half the trip at the other. And that's not the case. So you can't average it like that. You have to take the total distance over the total time. That means we've got to do some figuring. This is where we messed it up. The first portion of the trip, I'm going 10. So I'm going to just use one first portion of the trip. How do we figure out the distance traveled at that constant speed? So I'm going to call this d1. What's the formula? D equals d over t, d equals d times t. I can only write it down this one time. And then the other times we'll just insert our numbers. That was 110 kilometers. I use flat fractions per hour times 1.5 hours. When I say I use flat fractions instead of us, like kilometers / hour, it tends to work better in physics and stuff like this because it's very clear which is on the top. I can see right now my units, hours cancel, and I'm left with kilometers. And 110 times 1.5, you got calculators here, it's 160. The second portion. 6 minutes only. God, we don't have hours. 50 kilometers per hour. Well, let's get figuring. Portion 2. V2 is 50 kilometers per hour. That's 6 minutes out of an hour. Like, we need it in hours, not minutes. Well, that's 6 minutes out of 60 minutes for an hour, right? Can you do that math in your head? 6 out of 60? Or what? 10% of it. I chose that because it's easy. This isn't entirely accurate to the trip from Saskatoon. I just chose it for easy numbers. Saskatoon. 0.1. I added in a sig fig and I don't think I had that. I'm not worried about sig figs right now. Significantly, I'm not worried. Yeah, you may have heard it. Anyways, 50 times 0.1, I don't even need to calculate. That's 5 kilometers. Okay. That's the second portion. The third portion of the trip, 30 minutes at 150. $30, so half an hour. Half of 115 is 57 and a half. So all of these combined is my total distance. Right? So there's no quick way to do this, is what I'm trying to tell you. 1, 7, 30, 2, 27 and a half. I haven't finished the problem I got all to do. Now I gotta add up the time for total time. So I'm gonna put this down on average speed. I now have a total distance of 227.5 kilometers. The time is 1.5 plus this one, so 1.6 plus 0.5, 2.1. And so average speed, 108 kilometers. What that means is what we just figured out is this person who went 110, then 50, then 115 kilometers per hour throughout the trip would end up arriving at the destination the exact same as if somebody else went 108 and never slowed down. Right? That's what the average speed. I wanted to go over that again because I know you had a question like this. We're good right now? Flip it. Try something else. Velocity time graphs. As soon as I put this arrow, that means it's a vector. I'm very careful about it. Sometimes when I type in, I don't put the arrow on top. It's really tight. I'll point that out. Sometimes though, I'll use bold instead. It depends which program I'm using. And bold would also indicate that it's a vector if I don't have. The area under the line gives you displacement. Find the displacement in the first 3 hours. I gave something very easy because I said 100 kilometers per hour. That's north on this, right? You're going 100 kilometers per hour for 3 hours. I think you actually already know the answer. 300 kilometers north, right? But I want you to see this, thinking it through this way, and there's a reason. Start easy, then get tough, right? So, if I was to find the area under this rectangle, mathematically it's height times width, right? Or length times width. You could say it's base times height, another way of saying it. Okay. What is the mathematical height of this rectangle? Okay. It's 100, right? It goes from 0 to 100. And then the width is 3. This rectangle has a height of 100 and a width of 3. So if I'm going to do this by area, it's the exact same that I told you. But I'm thinking about this as an area. I'm going with a height of 100 kilometers per hour. Always use the unit when you're doing these areas. And the width is 3 hours. That's 300 kilometers. Now this concept that I am bringing this out here, my heart is despondent. What are the words? Do I need a book? Yeah. Got like, well, got a book. Not now. Okay. I'm bringing this up. I forgot to put in my notes because I got distracted. Really upsetting. Okay. Now that's truly a vector distance. Okay. I mentioned calculus. How many people here take calculus next week? Now, a big thing in calculus is finding areas, finding slopes. And actually, calculus was invented by Isaac Newton and some other people at the same time, but around the same time. But Isaac Newton invented it. because he wants to solve physics problems. So actually, physics is done best, and if you become a physics major or an engineer, you're going to use calculus, not these oscillators and these. Anyways, finding the area. It's called the integral in calculus. And you find out mathematically, area never made, like, you guys probably still think of area as something like centimeters squared, meters squared, feet squared, right? You can find the area with other units, and this is an example. And it's actually far more useful. It's not just that. Just like slope doesn't have to mean how fast a roof is rising. So it can describe something. Okay. Now, example 2. Here's one where we can't just look at this and tell me what the velocity displacement is. We do have to use areas in this case because it's not a constant velocity. I'm going to divide this up into 3 chunks. And you are too. And I'll draw in the last one. Okay. Green, red. I don't care if you call it 1, 2, 3. So to do this one, not 2, you're going to do 3 calculations for the area. How do we do the area of a triangle? By 2 half. 1/2 base times height, right? So I can go with the 1/2. The base is a unit of 1 hour. Height is 100. Kilometers. See if I can squeeze everything in. Plus the second zone. If this one is easy, it's a rectangle. Base times height there is between 1 and 3 hours, so that's subtracting 3 minus 1, 2 hours. Height is 100. We're keeping in mind everything is north. We'll add that in. Then once again a triangle. So 1/2 base from 3 to 4 is 1 hour. Height 1 hour. Squeeze me out. Okay. I think the arithmetic is pretty easy on this. You got calculators if it isn't, but it's 50 in the blue plus 200 plus 50 again. Right? Am I missing something? No. So, A, I've got this all broken up, so I've got the work down for everything. A. So A is, and we have it worked out above, right? The blue stuff. It's 50 kilometers north. I already said the answers. You got that? Like what I'm referring to is what I did above here. Right? Okay, and then your B is between 1 and 3 hours. Well, that's my green. That's 200 kilometers. There we go. 200. And 3 and 4 hours. That's a 50. All, even though the slope is going down, that just means it's slowing down. It's still traveling north because it's above the axis. whole thing, if you add those up, is 300. You add up all three of those answers. Now, I want to talk to you a little bit about this before we move on. And I know there's an average. First of all, what does that graph represent? Now, we'd already done the hard work. But this graph, the second, from here to here, because this is a velocity time, not a position time graph, what does this represent? What speed are you starting at? And what speed do you get to? 100. It takes you an hour, but you start out slow. Like, this is not realistic. It's just for calculation. In a car, it would not take you an hour unless you have a really crappy car to get up to 100, right? You do that within a couple minutes. You get 100. You do it legally, right? Anyway, that's speeding up. Then you set your cruise control for 2 hours at 100. And then you take an hour to slow down to 0. So slow down from 100 down to 0. But that's what that represents. They're never turning. They're always going off. That's okay. Velocity time graphs are pretty abstract. So then, find the average velocity between 0 and 4 hours. Well, average velocity, we know not to add three things up. We take our total distance. We don't even need to write the formula. Average velocity equal to the total distance. Oh, velocity, yeah. So, kilometers north. And it's divided by 4 hours. That's 3/4, so 7. Yeah. Oh, you don't? No. Good gracious, add it in. It's pretty easy. Average. You don't even have to say find E. Just put average velocity.